Okay, we're going to talk today about the tangent line. A tangent line is a line on a graph that describes how steep the graph is at any given point. So I want you to think about something here. I'm going to use a little ink here for just a second. So I'm just drawing on there. Imagine at this point here that there's a person standing on that point. So here you are, and you are walking up this graph. So this is your path, and you're going to walk from all the way down and across it, and up and down along this path. So right now, this person is going up, and he's going up because there's an incline, and I like to talk about exactly how steep that incline is. And the idea is that the incline steepness is called its tangent line. So imagine how steep it is at this point, and if I extended this as a straight line, that line will look something like that. And that is a tangent line. But notice as this person walks across this path, it's going up and down. Sometimes he's going to be going up, sometimes he's going to be going down. So that tangent line is going to change, and that's what we'd like to explore just a little bit right now. So I'm going to show you that tangent line real quick, and there's the graph of the tangent line. Now notice as you go from left to right, he's not going up as fast anymore. It's not as steep. And when he gets to the top of the hill, the tangent line should be a horizontal line. So at the top of the hill, and after he reaches the top, it'll start to go down, and that tangent line will show how steep the path is. So this is the steepness of the path is always going to be visually displayed by the slope of the tangent line. So that's the steepness, the same steepness. Now, the question is, why does that happen? Or how can we calculate the graph of the tangent line by the graph of the given function? Well, generally, the easiest way, if I was going to do it by hand, would be just to draw it visually. However, there's actually more detail than that. So I want you to think what would happen if you were able to zoom in. And now I'm zooming in on this point. And let me just put it in center as best I can. And as you zoom in, what I want you to notice about the graph is the graph of the curve is looking more straight at that point. I'll continue to zoom in. And I zoom in. Now notice, here's the curve, here's my tangent line. But as I zoom in, it's looking more straight. And I want you to think about that for a second. We're on this big sphere called planet Earth. And some people still think it's a flat plane. And there's a reason why people think it's a flat plane. Because when I go and look anywhere, it looks flat. You can't see the curvature of the Earth because you're such a small piece. You're so zoomed in on what you can see that you can't really see that curve. All you really see is something that looks flat. And that's the basic concept of how to calculate the tangent line. What you have to do is make a line between a very small piece of the curve, and the smaller the piece of the curve, as you continue to zoom in, the more flat and straight it looks. So, again, this is just the big idea right now, and I want you to let that sink in for a little bit. A tangent line is a line that looks just like the graph for a very small portion showing the steepness, But if I zoom out, I see the rest of the graph is very curved, and that tangent line is only matching the curve at a very, very, very small portion of it. Okay, I'll get a little bit more into the calculations on the next video.